we're going to talk about how you name compounds and write formulas. So first of all, if you have a simple compound made of one metal and then a non-metal, the naming is pretty straightforward. You name the metal, you name the non-metal, but give it the ending IDE. So sodium and chlorine becomes sodium chloride. Calcium and bromine becomes calcium bromide. Potassium and oxygen becomes potassium oxide. The subscripts in the formulas, again, are based on how many need to fit together so that the total of oxidation numbers is 0. The subscripts in this type of formula does not affect the naming. For compounds containing polyatomic ions, again, the naming is pretty straightforward. First of all, you could have a metal from the periodic table paired with any of the negative non-metals. So here, the first example, we have the metal aluminum paired with NO3, which is the nitrate ion. So it is simply named aluminum nitrate. In the second example, we have Na, which is sodium, paired with OH, which is hydroxide ion. So that is simply named sodium hydroxide. Another possibility with polyatomic ions is that you have a positive polyatomic ion paired with a non-metal. In this case, again, we name the polyatomic ion, and then we name the non-metal, and again, on the non-metal, we change the ending to IDE. So in this example, we have NH4, which is the ammonium ion. And then we have iodine, which would be named ammonium iodide as a compound. The third possibility is that we have two polyatomic ions bonded to each other. Again, we simply name the ions, put their names together, and that's it. So NH4 is the first part of this compound. That's the ammonium ion. CO3 is the second part of this compound. That's the carbonate ion. So we simply put them together. The compound is ammonium carbonate. Now, some metals on the periodic table can have multiple oxidation numbers. These metals are often transition metals, okay? In this case, the name of the compound will include a Roman numeral, and that Roman numeral will tell you the correct oxidation number for the metal in the pairing that it's with in the compound. Again, Roman numerals will go into chemical names. They will never be found in a chemical formula. So in our first example, which is already shown, we have CuS and Cu2S. Both are compounds of copper and sulfur. Again, two different combinations, so two different compounds with differing properties. They can't both simply be called copper sulfide. To distinguish between them, the first one gets the Roman numeral 2 because the correct oxidation for copper when paired with one sulfur would be a positive 2. So again, the Roman numeral 2 is saying copper has a positive 2 oxidation in this compound. So the name of the compound is copper 2 sulfide. In the second combination, the oxidation number for copper has to be positive 1 because there's two coppers paired with the sulfur. So in this case, the Roman numeral 1 is saying, hey, the oxidation for copper here is positive 1. So the name of the compound is copper 1 sulfide. In the next two examples, we have iron. Iron can have a positive 2 oxidation or a positive 3 oxidation. Our job is to figure out which compound is which. So in the first one, hydroxide ion, OH, is a -1. There are 2 of them. So iron has to be a +2 to balance them out. And the name of the compound would then be iron 2 hydroxide. And in the second example, iron would have to be a +3 to balance out the 3 hydroxides. And the name of the compound would be iron 3 hydroxide. Sometimes compounds are made of 2 nonmetals. Again, in this case, the first nonmetal is typically the positive part of the compound, and the second nonmetal is typically the negative part of the compound. But the nice thing is we get to use prefixes that tell us exactly how many atoms are present. There is one other rule, and that is that the first element, okay, will only get a prefix if it's a number other than 1. The second element always has a prefix, no matter what the number of atoms is. And again, because it's a nonmetal at the end of a compound, we still use the "ide" ending. So in the first example, we have 2 nitrogen and 1 oxygen. We need a name that literally tells us, put together 2 nitrogens and 1 oxygen. So dinitrogen monoxide. Okay, the prefixes tell us how many, and then the ending "ide" on oxygen. The next one is another combination of nitrogen and oxygen. Again, we need prefixes that say 2 nitrogen with 5 oxygen, and that name would be dinitrogen pentoxide. And in the second example, we have 1 carbon paired with 4 fluorines. So again, we want prefixes that say 1 carbon and 4 fluorine. And then I have to remember, oh, wait a minute, I don't use a prefix for 1 if it's the first element. So in this case, the name is carbon tetrafluoride. Okay, I don't need the prefix mono at the beginning. Last but not least, there's a rule about acids. First of all, you have to know that acids will begin with hydrogen and then will be followed by one of the halogens or a polyatomic ion. So again, if a compound starts with hydrogen, it is possibly an acid. Check what follows the hydrogen. If a halogen follows the hydrogen or a polyatomic ion follows the hydrogen, it is an acid and should be named as such. For the halogen acids, we name the hydrogen part, but only use the hydro of hydrogen. Then the halogen is named, but the ending becomes ick, okay, because acids are icky. So HCl is hydrogen and chlorine. Hydrogen followed by the halogen chlorine. So we use hydro from hydrogen. Chlorine becomes chloric, and we have hydrochloric acid. For the polyatomic ion acids, even though hydrogen is at the beginning of the formula, we do not put hydrogen in the name. Okay? The acid name tells us the formula starts with hydrogen. Then we name the polyatomic ion, and again, the ending is ick because acids are icky. Okay? Now, there is this minor rule about if we have 2 polyatomic ions that are very, very similar, like nitrate and nitrite. The one with more oxygen is the icky one, okay? And the one with less oxygen is the OUS one. So we have HNO3, which again is hydrogen followed by nitrate ion. Okay? Nitrate has more oxygens than nitrite, so it's the icky acid. And again, it's nitric acid. No hydro beginning. Even though hydrogen's in the formula, it is not in the name. Then we have H2CO3. That's hydrogen paired with carbonate ion. So again, this is going to be an icky acid. And so it becomes carbonic acid. Then we have H paired with SO4, hydrogen and sulfate. Again, sulfate has more oxygen than sulfite, which is actually the next example. So sulfate is the icky acid, and so it is sulfuric acid. Now, this is a bit odd because most of you would have said, oh, it's sulfic. Someone along the line decided, oh, they didn't like that, and they added back the UR from sulfur. Okay? It's confusing. I didn't make the rule. I'm sorry. Okay? But it is how sulfuric acid is named. The other acid that's like this, by the way, is H3PO4, which is phosphoric acid, not phosphic acid. Then we have hydrogen and sulfite. Okay, so again, this acid cannot be icky because SO4 is the icky one, so this one would be sulfurous acid. Again, naming and writing formulas takes time and practice. We will do a lot in class, but you will have to do additional practice on your own. Good luck.